put the following limits. Spot for the complex function there, which is the one here, the numerator has the complex functions because of the radical. So what we are going to do, we are going to use the find the conjugate of the numerator and use it to multiply both the numerator and the denominator. So the conjugate of this is this. So we now have limits as x tends to 9. So use that conjugate to multiply both the top and the bottom. If you do that, this numerator will be difference of 2 squared. So we're going to have x minus 3. That is a difference of 2 squared. That will be root of x squared minus 3 squared. And that will give you this all over x minus 9 into bracket this one. So x minus 9 will cancel. Then you have root x plus 3. So we now have limits as x tends to 9 of 1 over this plus what? Plus 3. Then you can now make your direct substitutions. Okay. The square root of 9 is 3. So that will be 1 over root 9 plus 3. And that will be 1 over. I'm going to the third one. Then after that, I'll come to this. We have limits as x near a, x tends to a of these quotient function. Okay. If you substitute, you're going to have 0 at the denominator. So I want to go that way. I want to avoid that. Okay. So what we are going to do is to find the conjugate of the complex one, the complex function. Okay. And that's the denominator. So the conjugate is what? So use that conjugate to multiply both the numerator and the denominator. So I use the conjugate of this denominator to multiply the top and the bottom. So in that case I'm going to expand this. So it's going to be this one times this one. I have this. And then this one times this one, that's a plus. Then this one times this one, I have minus a times this. And then minus. Then a times this. That's a root a. All over. This one, the expressions are the same, but they have alternating sign. So that calls for what we call the difference of 2 squared. This one squared minus what? This one also squared. So we now have this here and here. I think s is common. We can take it out. So and that will give us this plus. Here also is common. You can factorize that. And you have what? You have root x, and then the minus here times this minus here. That's a plus. So we have this all over. This one will be what? X minus a. Is that after we use the conjugates, we expand the numerator, and then we use the difference of 2 squared for this. So that's what we have. Then this will now give us limits as x tends to. This one will be x minus a into bracket this all over x minus a. So this one and this one will cancel. Then after that, you can do your direct substitution, and that will be equal to what? Anywhere you see your x, you put what? You put a there. So that will be root a plus root a. That's 2 root a all over 1. So that is the answer. The answer is 2